This is the video for homework 8, question 10. Show that if the normal process is wide sense stationary, then it is strict sense stationary. We know, we assume that xt is normal. That is to say, it has this probability probability density function. X1 to xn, t1 to tn equals 1 over square root 2 pi to the power of n and square root determinant c times e to the power of minus 1/2 x minus eta transposed and c times c inverse times x minus eta, where the matrix C here equals, these two are vectors, vector of different x's, and the expectation of this expression, we can expand it. That is expectation of this multiplication. This vector multiplies by this vector. And we notice that the expectation of xti is a constant, eta, because xt is a wide sense stationary. And we multiply it, we write it in another term, we find it to be this, r t1 t1 minus eta squared to r t1 tn minus eta squared, this term. And we rewrite it to the another form. This is r0, this is our rt1 minus tn, this is rt1 tn minus tn, which is also 0. And we can boil it down to ti minus tj, for I does not equal j, and ij are 1, 2, and up to n. And now we can rewrite this expression to be fx x1 to xn ti minus tj, for I does not equal to j, and ij are 1, 2 to n. We can now find that this expression here, which is all t's are added a small amount, epsilon, is actually fx x1 to xn ti plus epsilon minus tj plus epsilon for these island j's. And this is also, we can reduce this down to ti minus tj, which is exactly the same as this. So we can find that this fx is equal to this probability density, which means that this xt, it is strict sense stationary, because this satisfies for all ti, tj, and epsilon.